kinematic equations of motion. So what are the kinematic equations of motion and what are the advantage, and where we are using these kinematic equations and how those are applying to solve the numerical problems in motion in 1D and motion in 2D. Let's have a look. So first, kinematic equations of motion. And for the kinematic equations of motion, to take these kinematic equations, we have kinematic equations of motion. We have one condition. That condition we have to follow compulsory. What is the condition? The acceleration of the particle must be uniform. The acceleration of the particle must be uniform. Here I am considering a car. A car is moving with some initial velocity u. A car is moving with some initial velocity u, and it is uniformly accelerates. Initial velocity of the car is u, and it is uniformly accelerates after t seconds. After t seconds, what is the velocity of the car? After t seconds, what is the velocity of the car? In t seconds, how much displacement which traveled? In t seconds, how much displacement which traveled? And in nth second, what is the displacement? That we are going to take one by one. So first, see, from the definition of the acceleration definition is nothing but change in velocity upon time, v minus u by t. Then here we can able to write v minus u is equal to at. V minus u is equal to at. Then v minus u is equal to at. Then v is equal to u plus at. This is the first equation, and this equation is named as velocity as a function of time. Velocity as a function of time. When you know the all above factors, then you can able to find the velocity. Means if you know initial velocity, acceleration and time function, you can able to find velocity. This is the first equation of motion. Let's come to the second equation of motion. Same situation is same. Now we find first velocity. Next we are going to find displacement after t seconds. For that, here I am considering the average velocity of the car. The average velocity of the car. Average velocity is equal to, generally we are taking total displacement upon total time. Total displacement upon total time. Here I am considering the total displacement is s. Then v average is equal to s by t. Then s is equal to v average into t. S is equal to v average into t. What is a v average? What is average velocity? See here, initial velocity u, after t seconds, final velocity v. After t seconds, the final velocity v, from here v. But what we have to take? Average velocity means we need to take distance average speed or time average speed. Which one we have to take? So you have to take here according to the definition of the uniform acceleration. What is uniform acceleration definition? The equal change in velocity in equal intervals of time. Equal change in velocity in equal intervals of time is called uniform acceleration. Equal intervals of time means we have to take time average speed. According to the time average formula, what we are taking? Initial plus final by 2. Initial velocity v1 plus v2 by 2. Now just put the v average here. Then s is equal, you can get v plus u by 2 into t. V plus u by 2 into t. Now just put the value of v from equation of 1, from equation 1, from first equation of motion, v is equal to u plus at. Just to substitute this value in this expression, then you can get here s is equal to u plus v value u plus at by 2 into t. Now just try to simplify. U plus u, 2u plus at into t by 2. You can multiply t inside, that becomes as 2ut by 2 plus at square by 2, that s is equal to ut plus half at square, ut plus half at square. This is the second equation of motion. So what is the name of this equation? This equation we can name it as displacement as a function of time. Displacement as a function of time. Displacement as a function of time. Let's come to the last equation, the third equation of motion. The third equation of motion we can able to take as here. I'm using this expression. What is that? S is equal to u plus v by 2 into t. According to the definition of the acceleration, we are writing a is equal to v minus u by t. Now I am writing t is equal to v minus u by a. Just put the value of t there, then you can get s is equal to v plus u by 2. It's just I am writing u plus u as v plus u, just for our convenience, and the t value v minus u by a. So then s is equal to a plus b into a minus b, a square minus b square by 2. So nothing but simply v square minus u square is equal to 2as. So this is simply the equation of motion, what we are named as displacement, velocity as a function of displacement. Velocity as a function of displacement. See here we have three equations. First equation, velocity as a function of time. Second equation, displacement as a function of time. And third equation, velocity as a function of displacement. These three are the basic equations of motion. Now actually here by this equation we are finding that velocity after t seconds and displacement after t seconds and velocity after s displacement. But now I want to calculate what is the displacement in exactly the particular timing, means in 5th second of its journey, in 7th second of its journey, 10th second of its journey. If I want, then how to I can calculate. If I want the 10th second of its journey, 10th second, then how to we can take. If anybody asking 10th second, then what we have to take? 10th second means we have to take 10 seconds minus 9 seconds, that will get 10th. Means here I'm going to take the displacement traveled in 10 seconds, the displacement traveled in 10 seconds minus the displacement traveled in 9 seconds. So is it 10th or not? Is it going to 10th or not? So total 10 seconds, in the 10 seconds, so first 9 seconds how much traveled, then remaining is the displacement traveled in 10th second. So simple. So here if they are asking about 9th second, then how to we can take 9th second. So very simple. Displacement traveled in 9 seconds minus displacement traveled in 8 seconds. If they are asking 4th second, displacement traveled in 4 seconds minus displacement traveled in 3 seconds. Yes or no? Yes, of course. Now the displacement traveled in nth second we require. Displacement traveled in nth second. Can you guess how do we can take? 10th second how we took? Displacement traveled in 10 seconds minus 9 seconds. Displacement traveled in 9 seconds. How we are taking for another 8 seconds? 8th second. Displacement traveled in 8 seconds minus displacement traveled in 7 seconds. Like here, if you want nth second, how we can take? Yes, you know that. Displacement traveled in n seconds minus displacement traveled in n minus 1. This is the displacement traveled in nth second. Yes or no? Yes. Displacement traveled in n seconds minus displacement traveled in n minus 1 second. That is the displacement in nth second. The displacement in nth second is equal to displacement in n seconds minus displacement in n minus 1 seconds. So just to put the value of, you can use the equation of displacement as a function of time. Displacement as a function of time, what is the expression? S is equal to ut plus half at square na? That's only take u time how much? N plus half a time how much? N square t square minus u into n minus 1 plus half a into n minus 1 whole square. Now un plus half a n square minus un minus u plus half a into n square plus 1 minus 2n. A minus b whole square expansion here, a square plus b square minus 2ab minus 2ab means like that we are getting. Now try to further simplify. You can send this minus inside, then what will happen? Sn is equal to un plus half a n square minus un minus of u plus u minus half a into n square plus 1 minus 2n. N square plus 1 minus 2. Any cancellations here? Yes, you may cancel this. Next, write one more step. Sn is equal to half a n square plus u minus half a n square minus half a plus 2n into half a. 2n into half a. Let's see, half a n square cancel. Here 2 cancel. Is there anything? No. That's all. So then Sn is equal to u plus an. Here an is there minus half a. So you can able to take common as a. Then u plus a into n minus half. U plus a into n minus half. This is the displacement as a function of time. You can take 2 as LCM, then you can get u plus 2 take common outside. That also becomes as 2n minus 1. This expression represent displacement of the body. Displacement of the body in nth second. Displacement of the body in nth second. In nth second. So that is the one equation of motion.